with you again this evening. So I really, really do hope that we learned a lot yesterday, or we did enjoy yesterday's section. And what we're going to be doing today will be a continuation of what we did yesterday. But for the sake of a quick recap, I'm going to take just a, for the sake of, for us to be on the same flow, I'm going to do a quick recap of the workflow we created yesterday. So we'll be on the same page. Then we're going to complete what we started, and we'll do a revision of all what we've covered this week. So before next week, we'll be better prepared for our next session. Okay. So by now, I want to believe most of us must have had the tools downloaded, or must have had it installed on our systems, depending on your operating system. And when I mean the tools, I'm talking of Git, Visual Studio, Python, and setting up your CLI like as we created yesterday. So without further talk, let's go on. Oh, and again, if you're joining for the first time or you're seeing me for the first time, my name is Chidiogo Choice Ugwede. You can call me Choice, you can call me Chidiogo. That's fine. And I'm your co-facilitator for this data engineering section. Okay, so I'm just going to take my face out for a bit and we'll start with what we have for today. Okay, just give me a second. Shut the screen. All right. So yesterday, the last part we stopped at was when we talked of collaborating your work on GitHub, pushing your work to GitHub, and you making use of Git for version control. And I did a small demo showing you how exactly it works, showing you how the history of your project is going to come live on GitHub. You're going to work on the back end on your local device with your Git commands, and you make your push to GitHub. So Git is like the back end commands of everything of how you're going to, set up your repository on your local, connect it to GitHub and whatnot. GitHub will give you a good interface for you to see everything come live. And we talked of some very notable terminologies in GitHub and Git. When we talked of the remote, I told you exactly what it means. I told you how it means, like a server hosted copy of a repository. I showed you how a repository looks like on GitHub and some different sections in the repository that actually matters. I also showed how to set up a repository on GitHub to enable collaboration and to serve as a project backup, because it's not every time that we can trust what is on our local system. Accidents might happen, things happen. But if you push your work to GitHub, you push your work onto GitHub, it will always be there, because I don't think GitHub is going to crash anytime soon, or unless you lost access to your account, which you can always recover, but it would always be there as a backup. I showed you how to, I've not showed how to merge, but we're going to handle that today. I'll show you how to create a new branch. And I told you branches are like different, like a different folder you're creating in your project directory, that okay, you want to say, let me do some testing on this branch. Then if the testing works, you can then merge from the branch onto your main branch, as like a main code base, to merge the two jobs together. So that's also another technique that we're also going to go through again tonight. And I did show you how to commit, how to use the commit and commit your work before you push to GitHub, because you can't even push without committing. That's number one. And number two, you can't commit without writing a message. You have to tell GitHub why you are making this commit. And I showed you how it comes into play later on, because you can easily see the message for the commit and know exactly what was going on at the time that change was made. And I told you, in proper production environment, not only are you going to see the message of the commit. You should see the author of the commit. You should see who authorized that commit. You should see the exact place the change was made. You should see the exact reason the commit was made and whatnot. So that's a very, very interesting concept, and that's part of what Git slash GitHub provides. So just to also recap on every single thing before we even go into the commands of Git, I did mention that the whole purpose of this your workspace. Now, I wanted to correct one ideology that we're coding yesterday. 'Cause I saw almost comments saying you didn't understand the coding part and whatnot. We were not coding. That's why the example I gave for the push to GitHub, I intentionally made it a text file, a txt, so we would not get our hands dirty yet with any serious coding, so we won't get disinterested before it actually gets interesting. Okay, so what we are doing is to set up our environment, set up our workspace. We are setting up our system to be able to code. So we've not started coding yet, but we will. But before we do that, we have to set up our workspace so we'll be able to code. And now, what are the workspace that we set up? The first thing first I showed you was your Python. Once you install your Python, and not just going to use your Python that way, it is best practice to create a virtual environment for, so each project you are using, you'll be using a particular environment of Python, and that particular environment will come with its own specific Python packages that that project require. I showed you how to create a new directory, which is slash create a new project on your paths using Linux command, and you do this on your CLI. It must not necessarily be Git Bash. You can use any CLI of your choice, but I do personally recommend using Git Bash as a more preferable way to write Linux, right? So that's that. I also did mention about Visual Code, and I told you that you can also use Jupyter to write your Python code. But in the course of our future, what we'll have to keep on working on, Visual Studio will be much more preferable to cover the rest of those sections, and it is a much more production friendly environment to actually write your codes in. So we are yet to be pros. So that's why we are going to have to use what pros use. Okay. Now I also now talked lastly on Git, which was what we were covering yesterday before we ran out of time. So Git, like I mentioned earlier, is a version control tool. And what's a version control tool? It is going you can easily see the history of your project. It will help you organize your project in a way that when you make changes, you can easily go back to a previous version of your project without anything canceling or anything, not working properly. Another thing that it enhances is collaboration. And I showed you how Git enhances collaboration because you can make push from Git to GitHub. And I told you that Git and GitHub are not like, they're not the same thing. Git is like the back interface you are going to use to set up version control in your project. Then GitHub is it hosts a repository in which you can push your project to. So you would have your project right there online on the server. And I've showed you how to create a repository on GitHub. You can either make the repository private, you can make it public, depending on the scope of your project. Now that's like enough recap. Now let's move on again to the flow of GitHub. How do you create the flow of your Git command? Because that's the last thing we were doing yesterday. So to quickly refresh our memories for the flow we were working on yesterday, what we did was we created a simple project, and the name of our folder was Incubator. So this is it right here on our Visual Studio. Remember, we created our project on Bash. From there, we did code dots to log on to open the IDE, which is our Visual Studio for this code. Then I opened an integrated terminal on Visual Studio. And how I did that was to come onto your file in your project. Once you right click, you will see the option to open a new file. open in integrated terminal. So this will give you a special terminal, just the same like your Git bash, same as your PowerShell, any other CLI you have in your system. It will give you that same interface right here on Visual Studio. And I told you that it is not only one type of CLI or one type of terminal that Visual Studio has. It depends on the flavor you are most or the type of CLI that's most compatible with your project. And I told you personally, I do work with Git Bash because it handles a lot of Linux languages, broader number of Linux languages. So I use that as my default terminal, default CLI on my Visual Studio. So that will be of personal preference to what you prefer for that. So I set up Git on our project. That was the first thing we did. Okay, no, the first thing we did here was to create our virtual environment. So this was our virtual environment that we created. I remember the command for creating virtual environment. You do your Python /m, then venv, indicating that you are creating a virtual environment, then the name of your virtual environment. And in this case, the name of our virtual environment, I named it Incubator. So whenever we see this virtual environment, we know that it belongs to our project called Incubator. And that's what we're working on. And I showed you if you want to recreate this environment somewhere else, and if you want to get all the packages you installed on this virtual environment, you do your pip freeze, which is like the command pip freeze, then the name of the file you want to write it into. And in this case, we chose the name of the file as requirement.txt because it is a standard practice to write into requirement.txt. And if you open this requirement.txt, you will see all the sample packages we installed on our virtual environments, on our Python virtual environments yesterday. So the next thing we did was also to create a file in our folder. I remember the name of the file we created was collins.txt. And all these changes on local, how it reflects on GitHub. So that was exactly where we stopped yesterday. And to recollect your memory again on GitHub, this was the flow on GitHub. This is the flow on GitHub. So we created a private, I created it, made this private because it is just an internal workflow that we are working on together in this class. And I did it in a branch called main. Oh, before I even go to deep into that, I wanted to do a proper recap for you on needs. So when you start up your project, you have a new project, right? You first of all do your git init, and you are telling Git that you are setting up that repository, you are setting up that repository to be tracked by Git. Okay. Now the second option is to then, not the second option, the second step rather, the second step is to then do your git add dots. And I tell you, this dots means that you are referring to the directory, like take everything in the directory. So you're putting it on the stage saying that this is about to be committed, aka this is about to be saved. So once that is saved, it already becomes a version of your project. So you can essentially move back to that version after this is saved. If you like make another change again, then save it again, that becomes another version. So you can also move back easily to the previous version without getting lost on what area you made your changes to. Okay. So let me get back on track with this. So the first step again is to do your git init, which is to set up your repository for tracking. The second step is to do your git add dots, which will stage all your changes in that folder directory. It is on your project directory. It will save everything for to be committed, that to put it on the stage so it will be ready to be saved, that's ready to be committed. Then the next step is to now run your git commit /m. And I told you this /m means you're about to type in a message, which is compulsory. It is not optional. If you are making a commit in Git, you have to put a message on why you're making a commit. So once you initialize, you add to stage, then you commit. Then once you commit, this is for a new project, right? Okay, sorry about that. Let me put it on the slideshow. No, let me just start from current slide. That will be slide 14. Yeah. Again, now that the screen is bigger, um, we can see the steps I'm trying to, you know, remind us of here. So the first step is, again, I'm repeating that as the Git init. We are telling Git that starts tracking my work in this project folder. We are initializing a version control on that folder. So after that, we are now going to run. The next step is git add dots. And I told that dot signifies everything in that directory, everything in that project path, like wherever that project is located, every single file in that project, let it be put on a stage ready for commit. So once you do that git add, if you make any changes, it is going to tell you, oh, I've added so change to be made to the file, I've added so change to be staged, ready for commit. Then the next step after that is to then do your git commit. I told you git commit must always come with a commit message. That's how you see it coming with hashtag flag M. So it is going to commit your work. And I told you commit is another fancy way of saying save in Git. So once you initialize, you add to stage, then you commit. Now, this next two steps, that's these two steps right here, it is mostly for a new project, when you're starting a new project. So you have to identify the branch in which you're working with. So it is best practice to be named to clean. So everything will be clean. So after that, again, this is a new project. You have to add origin. Yeah, that you have to do your git remote add origin. I told you what this does is that it makes you connect to your GitHub repository that I'm sure you must have created. So if you create a GitHub repository, you get a specific URL. They call that like the link to that repository, the link to that server. So once it gets that URL, and I showed you where it is always at the home page of any repository you create, especially any new repository you create. It is always there at the home page. So if you run your command git remote add origin, paste the URL name, you're automatically connecting your local Git to that GitHub repository you created. Okay. Now, the next step, which will be repeated multiple times during the course of a project, the next step is to now push your files to origin. That will then be the git push flag u origin with the name of the branch on your local device, which in this case, remember that we renamed the branch to main. So we're not saying git push to origin main. So you are pushing everything from main to origin. And remember, in this case, origin is standing in place as your GitHub repository. We renamed our, right here in the second to the last step, we've named this URL as origin. And I told you that origin can be different name. You can name it anything you want. It's not a must, it must be origin. But for standard practice, it is best practice to name it as origin. So when you're making your push, whether you just wake up from sleep or it is late at night, you won't be cracking your head to think of, oh, what did I name this URL as? I can't remember what I named the URL as. But it's best standard practice to just name it as origin. So whenever you make your changes again and you want to push to that GitHub repo, once you do your git push to origin from main, it automatically gets uploaded to GitHub. Okay. So now, for another clarity's sake, let us run through these steps again. Okay. I'm not going to add to that's minus the step of git init because we already have git initialized on our project. So I'm not going to run git init, but I'm going to make changes to my project. Then we'll run the git add. We would run the git add, we would run the git commit, and we would run the git push, because these are the steps that is going to be done over and over when you're making changes to your project. Now note, I should have added it to the slide, these steps right here that are listed as your first git command, it is only for a new project. But once you are done with this first set of steps, for after you've made your first push, any other other step you'll be doing is just to, whenever you make your changes on your local system, on your local Visual Studio, when you make your changes, you will do Control S to save it on your local. Once you save it, the next command is to do git add dots. You are now going to stage your change, then git commit to commit that your change, then git push. And this done because you've already named your URL as origin. You just simply do your git push u origins from main to origin. Simple. So after you're done with your first set of push, you're only going to just be running three commands: your git add, git commit, and git push. That's all. So now let us see how we would use these three commands to see how the workflow works, how the changes occur in GitHub. Okay. So now back to our Visual Studio. This was the file we were using yesterday. We were making use of this collins.tsc sample file. So let's make some changes to this file. You can really see right here that I typed something right here on my Visual Studio. Already you can see that the file has changed. It is not telling me this has been modified. It will immediately tell me this has been modified. So it's a very fancy way of tracking changes in your project. So that's just another by the way. So now let us type this here. So say today is day 3 and we are learning Git. Okay, so now remember the first step, we are going to do Control S on our local. So after Control S, the next step right here is to now do our git add dot staging everything. Git command not found. Why is git command not found? Okay, just let me set up our virtual environment. Activate. Okay. What is going on? Okay. It's not before we even add the git commit. I think my terminal doesn't like me tonight because we can see git worked on my terminal yesterday, but today it is telling me it can't find the command, which is pretty interesting. So let me set up a new terminal. Okay. Okay. Okay, so we are back. So we've staged our change. We've done our git add dots. We've staged our change. Now the next step is your git commit. Now remember, you have to put your git commit with a commit message, right? So now what we are saying is making changes to track history. I think that's good enough. So once we've done this, it has told us, okay, yes, I can see you made a change to one file. I can mean we've made the change to one file and we made 3 insertions and whatnot. Now let us push our change onto GitHub. So that will be git push u, okay, then origin. Then where are we pushing from? We are pushing from our local main. So give this some time. Okay, so I can say because it's possible to set a new terminal while doing your job. It's not necessarily a new terminal because when I still open this terminal, it automatically opened my virtual environment that I set up, automatically opened the Git that was already set up on this project. So it was not necessarily a new terminal. I just still went back to my project directory, right clicked, and I opened an integrated terminal. So it will still keep on set as long as you've already set up that workspace initially. If you keep on clicking on this, if I click on this again, you can see the previous one I was working with here. The new one I was working with here, it's also still coming directly with my source activated, with my virtual environment activated. You can see it, and also with my Git virtual environment, and it has already set up my Git branch. As long as you are doing it in the same project which you've worked on. So I can delete this terminal because I do not need it. So Q, yeah, Q is fine. So I guess what happened with this one was that it was, I don't know, it just opened up. It just opened up as open my virtual studio, and I didn't necessarily make use of it. So it doesn't matter. So now we've okay, our push has been done. So let's go back and see. So once we refresh our GitHub, see the change we just made, making changes to track history. And if you should click on the commit message, you will see the change we made. This was the new line we added. We added this new line right here. Today is day 3 and we are learning Git. So if you want to see the full history of everything that has happened on this file, if you want to see the full history of everything that has happened on this file, we'll just go right here back to code, and this is actually where to the commit. That means you've pushed and pushed 4 times. So right here, you can see the 4 commits that we made. The first one was that we pushed our first work to GitHub. So if we click on it, you see the first line of code that we wrote. And this was the first line of code that we wrote. We sent an empty collins.txt. You can see that there was nothing in the file. Then we sent the first commit we did, right? So now let's go back. You see the second commit we handled. Let me go back to the okay. So we'll see the second change we made, which is made a paragraph for Collins. So this is the second commit we made to this folder yesterday. So if you click on it, you can see the 3 first paragraph we added. Do you notice that all the new lines we even added today, you can't see it here because it is just giving you a history of all the changes you made on this file at each particular point in time. So this is the second commit we made. This was when we initially wrote something in collins.txt, and we wrote 3 sentences. And that's why I said made paragraph for Collins. We wrote these 3 sentences and we pushed it to GitHub. So this is all what is going to show us that, okay, this was the changes you made the second time you pushed, right? Now let's go back and see the third change we made. Which is made a paragraph for Collins. Let's go back and see the third change we made without it clicking. I believe we already did this. line in Collins file. So you can see right here, this was the changes we made to the file. We most likely to line 4, something like that. But I know this was the new line that we wrote. We wrote there are currently 26 people in the chat. We wrote that here on this file and we pushed it to then today. Fourth commit, which we just did today. So you can see these are the changes we made today. You can see the two lines in green, the line in green right here. I think I must have made a move with this one, but technically this is what we should, this is what it is changes to one line, which is line 7, where we wrote today is day 3 and we're learning gits. So this is how your commit history will show. And if I want to show you how the collaboration works, access to GitHub, and the person will have to like write and push to this same repository. Once the person make a push to this repository, the way it will not show is that it will not show you, oh, this person made a push. Okay. Let me show you an example project. Let me just look for one example project that I collaborated on that will drive this concept home. So let me stop sharing my screen for a moment and actually find something that we can use to drive this home. Okay. This is this. No. Summation for cycle 15. No. Okay. Yes. Work with this. Trying to just load this repository and load the commit history so you will see exactly how the history works. So very good. Okay. So I'm sharing my screen back now. Okay, can you see my screen? So this is a project that I collaborated on with some people, some fellow engineers, right? So they made the commit, or this person authored the commit. You see the fellow contributors or they made the commit. The file. You see this red line right here, it have shown, okay, this line was added at the part or at the stage of this commit. So in this commit, even though I can't recollect what happened at this stage, but if I come back to my GitHub and I look into it, I'll be like, oh, okay, I did delete this line at that time I saved this file. So you can see the way not only it even helps you recollect, okay, what you did previously, but it will show you exactly what happened at time of that commit to show you what people. You will see the different people that made in the commit. So right here, as you can see, you so right here, as you can see, you will see the author that made the commit. You see the exact line and the date the commit was made. So as you can see it right here, the name of the author, the date it was made, if the commit was verified, if the commit was approved to go on to the main your base code. So this is just one example of how collaboration works. Another thing you will see right here is that you would see the different contributors to repository. When you move on to a repository, you will see the different contributors to that repository. So this is the homepage of the repository, which is still for you. Okay, this has loaded. So you can see the four names listed here and exactly how it to show how each team member to the project. So it is a way to collaborate with your team members. It is a way to track your changes made to your commit. So let's move on with the rest of our slide, and I will actually be entertaining questions tonight on not just what we covered today or what we covered yesterday, even back to what we covered on Monday on the fundamentals. If you had any questions for Monday, today will be the day you can ask any questions. Yes, so the collaborative workflow of Git. So let me expand this slide. So like we did yesterday, the first step is to create a repository. So you have to set up your new project on GitHub. And again, I showed this step by step, the steps to create a repository, and the different sections in which you need to take notes of when you're creating a new repository. Now, this step two this step two is a way you can say, oh, you want to make that, when we created our main folder on our local, this is what step two means: clone locally. So when you do your Git branch main, you've created a main folder, and once you do your remote add, technically you've connected your local folder to the repository on Git. So that has been settled. And I don't want to actually go into the concept of cloning because it involves already creating from someone else's work. So clone comes in when you already have a GitHub, someone else already have their project set up on GitHub, and you want to work on that project on your local. So what you will do will be to clone that project. That is a fancy word for saying make a copy of that project to my local. So from there, you can now set up a repository on your local and make your changes to that project. That's in this case, you're adding new features, you're adding different things. Then you save your change and upload it to GitHub, right? So once you then upload that change to GitHub on that same person's project, then you can make sorry, give me a second. Okay, apologies for that. It was a very, very, very urgent phone call that we had to take along the way. So now back to what we were discussing. I was telling you on the concept of collaborative workflow because everything we've been working from scratch with your own project. But what if you want to collaborate with someone else on already created project, right? That is where this workflow will come in. So when you want to create a new project from a project that already exists, you have to clone that project. As you go to that person's repository, you will make and take a copy of the person's URL, right? Come to your own local device and make the change. Let us walk through it together step by step. So first thing first, let's say I don't have incubator on my system, and I want to clone this our project that we created. I want to make a copy of it on my own system, then make a push to GitHub. Let's say I want to do that. So what's the first thing I would do? Let me create a folder for the project on my system. When I mean on my system, is another way of saying on my local, right? So first thing first, let's create a directory. Remember, we already have an incubator directory, so I want to make this another word. So let's say testing, because we are testing collaboration. So we're making a directory called testing. So let's cd into that directory. That's the first thing first. Now the next step is to now clone the repository from online, right? So now let's go to our GitHub. I hope you can still see my screen. So I told you that you will find the URL of every repository on the GitHub homepage. This is the GitHub homepage for our project, right? This is the homepage for our project. If you click on this drop down right here, it will show you, give you the code, the URL to this project. So again, I will reiterate, you will come to your dashboard for your GitHub project, click on the drop down for the code, and copy the URL. Okay? So once you've done this, you'll be able to clone the repository onto your own personal system. So what is going to be the command for that? So we'll just do git clone, paste the URL, and that's all. So you just wait for it to clone it and set it up on your system. So it has cloned it into a folder called Incubator Workflow on our system. So now, if we should list out everything in our testing, you will see that we already have our Git that was set up, our project that was set up from GitHub, named Incubator Workflow. Remember, that is the name of our project on GitHub, Incubator Workflow, which we've cloned into our local device. So now let us now cd into Incubator Workflow and make changes, then push the change back to GitHub. So we'll cd into this change, into this into the project on our local. We are in the main. Now remember, we'll open the cold dots. So automatically you will see a Visual Studio interface showing up. So once you open this, automatically you see everything that was on our GitHub and without any device. So if I should open on this project, sorry. So if I should open our integrated terminal, automatically you will see the git control. The git do is let us make changes and see how it reflects there on our GitHub. So now the next change we're making is into the cloned device. Yes, good. Now Control S, save. Now let's come back here. We add. Let's do git add. We are then going to do git commit from cloned workflow. Then the next step is to push. So now one thing I don't know if is okay. Yeah, origin still serve as the main thing, so I think it should still be the same. Okay. Now we've made our push. Let's go here and see what's changed in our repository. So we refresh this. My goodness. Apologies for that. I was muted. Is it better now? Is it better now? Okay, I think I'm hearing myself, so we are good to go. Okay, so all what I was saying was project layouts, and I was trying to explain how it is essential to create a good project layout, because it is not only for your current project you're working on, because you would always come back to want to, relieve. Because me, I personally, there's some projects I work on that months later I would need to reference that project. Now imagine if I had not arranged the project in a way that I could easily come back and understand what was going on. E.g., if I don't put all my scripts in one particular folder, if I don't arrange all my functions in one particular folder, if I don't have a particular folder for the logs to see exactly how the script ran, it will get confusing. So that's why another thing we need to know in our setup is how to create a scalable project layout. And this thing is not a necessarily technical skill you must know. I will most likely call it a soft skill, because it should fall under your documentation skill on how you properly document your project for future Okay. Okay. So again, sorry about that. We had that. My network did glitch for a bit, but we are back. So what I wanted to show was the proper flow of a and I mentioned something about day. So it's not necessarily every time that you have a dedicated folder for data, because most times going to be projects. So I do not believe you have to set up or bring in your data on this hub, your organization's data. For the purpose of building the data folder is if you are doing a project on your own, want to showcase or add to your portfolio, you can then create a folder to just show a sample data of the process file you created. Do you understand? Flow, but I'm trying to open a repository as an example for, okay, okay, let's see this. So I'll be sharing now. It shows the single. Let me before I expand folders, you can see a folder for my downloading. I have a folder for the bar. I have a folder for its immediate transform. I have a folder for reading. I have a folder for Docker pipeline, and this the log of how the pipeline works and the scripts that run the pipeline. So you can see if I want to start this project, it will be quite easy to do because it is quite that I can come back to see exactly what each of my first projects. So if I should click on the job down for DBT workload, you can see every aspect of the DBT that I'm going to go for in details. It's very interesting. We are going to learn. Next is then the scripts and details is what is implemented and what can change. Right? So it is best it's best to use naming convention. So use a descriptive name. Don't just get creative like me. It is best practice to use a come back uh, to look at the project to understand you know what to do right now. Okay, so we are back. Apologies once more for the network glitch. So we have two more slides to present. I'm just going to try to take it easy and because I want us to grasp everything that needs to be grasped. So we have one more sector to look at, which is our naming convention and best practices, right? So like I mentioned, or like I was mentioning rather before network, kicked me off the call. If you want to name your files or your work, it is best practice to name it in a way you'll be able to easily understand what it was when next you come to check on the project. So imagine naming your scripts as script1.py. .py is an extension for saying it's a Python script. But imagine if you had actually named it as clean customer data.py. So when you come back to this script month later, you can easily tell that, oh, the function of this script was to clean your customer data. So your name should reveal what the script intends to do at first glance. That's one best practice. Another best practice is to separate the concerns. Just like the example I showed you for that repository, I kept all my scripts in one folder, kept the tests in another folder, kept the data in another folder. This will prevent mixing up responsibility and it will simplify debugging. Another thing is to document thoroughly. There cannot be so much emphasis placed on proper documentation. Like I mentioned, I think on Monday, that documentation is not just for you, it is also for your legacy. So when next someone is coming to work on that project or to continue on the parts of that project you started on, they won't have bad thoughts for you because you are not going to they will look up to you that, oh, this person actually laid a very good foundation for this work, and they'll easily know where to pick up from and where to integrate from, right? And it will also help you because if you are going back to the project months later, you can easily go through your documentation and know that, okay, this was what I implemented, this was what I made changes to and what's not. Okay. Another best practice is to use .git ignore. So I showed you what git ignore do, what it does. I showed it yesterday, and I said it is going to exclude unnecessary files. When you're making your push to GitHub, it is not necessarily all the files you want to push to GitHub. Take for example, if you have some multiple log files that you necessarily don't think you need people to come and check and see the way your pipeline ran or every single details, you can put your log file in your .git ignore. So whenever you're making any change, any push to your GitHub, the log file won't get pushed to git ignore. As long as it was added, it won't get pushed to GitHub because it was added in git ignore, right? Another example of things you can put in git ignore so it won't get pushed to GitHub is your credentials. So if you have a file on your local system that contains your credentials that's in your project, you can add it in your .git ignore file. So when you're doing your git push, the file won't get pushed to GitHub. So it will be safe on your local and it will keep everything on your GitHub secure. Okay. Now, critical files as needed for every project. Like I mentioned yesterday, your README is like a very intensive or extensive document that will show every single thing about your project. It will give documentation on the setup, the usage, the overview. It is the first thing people see whenever they come onto your repo. Your README is the first thing people see when you open your GitHub repository. The README is the first thing they see. Just like the if I should open this GitHub repository, come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first thing you see is the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first thing you see is the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first pop up the README. This is coming on. So, if you come to the home page, the first pop in this home page of the project. So once you come into see and the way you capture set usage so this if I maybe for example I don't TSC on because but I can just easily write. Did I get kicked out again? Okay, no. You can just this dot git ignore. When I do your git push, the file won't get pushed to GitHub. That's the purpose for git ignore. And when we are doing project exponents of it, another important file you should have for every project is your requirements.txt because it will contain all the packages and dependencies that the project needed to thrive, right? And your config file. Config is not necessarily important for every project, but it depends on what you're working on. So I'm going to leave this as it is because we are still going to build project hands-on together. So you will see the real life implementation of these changes, of these critical files to be added to your project, okay? So now the next step I want you to do on your own, take this as a take-home assignment. I want you to make sure you set up your Git locally on your system. Let me expand this slide. I want you to make sure you've installed Git on your machine. And I told you that once you install Git on your machine, you're going to use Git config. Right here in the slide, you just type git config. Once you type git config, it will give you the prompt to put in your username, put your email. That's I'm talking of your GitHub username. So by this time, you should have already created a GitHub account. You put in your GitHub username, your GitHub email concerning that, and anytime you make a push, you have to make a push from your local to your GitHub. Automatically, it is going to use those details to identify your commits. Now, the next thing I want you to do is set up a simple project on GitHub. You're not coding. Just set up a workflow. You can write a text file like I did. Then try and see if you can make a commit to that project on GitHub. Make push to that project on GitHub to strengthen your hands how to properly Git to integrate with GitHub. And that's how it is organized like a professional. But Okay. Publish. So I need to talk about hearing back from you, because this is for this week, because I don't want to have to bad you with so many things to note. So we're going to take it one after the other, right? So now, do you have any questions from the sections we've covered this week? So we'll quickly look at it together, since I don't think network is going to permit me to start switching between GitHub and Visual Studio right now. Let's talk and break down any complex, any part you find complex. Let's break it down together. Okay. So I'm going to show how to make pull requests on projects, because a to make a request from outside, but I can run on how pull requests work. So if I working like part of so together, that is something called a pull request, and this is it right here in GitHub. I'm currently sharing my screen. I hope you can see it. Collaborators will join their work together and merge it into one. So let me try and see if I can see the history of I assume I have a fellow team member right here that made a common new branch, and they want to merge onto our main code base. If they create their branch on the repository and they want to merge into the main, they are going to record a merge possible. So it is very project, so you'll be able to see it hands-on how pull requests work. But that's basically the structure of it all. So since there's no network was really bad, I will try how you code on your local to integrate into GitHub. And I've showed you how GitHub is going to structure your code, your project in a way that you'll be able to collaborate with people, you'll be able to see histories of the changes made on your project, and you'll be able to save your for future purpose, and in case of any crash or anything to your system, your project would always be there. Okay, so I showed the git commands, the essential git commands, which we covered like thoroughly in the beginning of this section today. So I told you, if you're starting a new project, these are the commands you use. But if you've already created a new project, the only commands you have to you will keep using is your git add, git commit, and your git push. So once you've already done your git init, that's to set up a new repository, and you've done your first stage, you've done your first commit, you've created your branch on your local, you've added your origin on, to be able to connect to GitHub, from your local, to be able to connect to your GitHub repository, and you've made your first push. Any other change you need to make will just be to save on your local, do your git add to stage the changes, do git commit to commit the change to your repository, and do your git push to push the change from your local to your GitHub repository. And then I showed you project structure, the layout of a project structure in a GitHub repo, and I told you that you will see it better and understand it better when you work hands-on on your project on your own, or during the course of these sections when we work on projects together. You will see exactly how the project structures comes into play. Okay, now another thing I wanted to note was the best practice that I did say for creating a project. So you need to be able to name your files clearly. You need to separate your scripts, separate it into different folders. You need to document thoroughly and use your git ignore. And again, the general purpose of this section was just to set up our space for building pipelines for coding. We've not started coding yet. We're just setting up our space for coding. So before our next section, I want to now be sure that we already have everything we need to actually start coding. So which is our Python, Visual Studio, your Git, and your CLI functional. And in this case, I told you that best practice to install Git bash as your default CLI, because it just takes in a lot more language than all regular terminals on our system. So I think that would be all, but I do not want to leave us tonight because I really want us to make sure we've covered all the fundamentals, because from next week we'll be getting our hands dirty and going deep into some of the core tools for data engineering. So this week was for preparation and for us to understand the fundamentals and to set up properly. So once again, you can reach out to me on LMS. So as Stress Grade, if you have any issue with your setup, you can reach out to me and I would see any way I'll be of assist. I'm going to assist you. Or you can also reach out to any of the co-facilitators and they would assist you in setting up properly. Okay? So before next week, we can work hands-on together, and it can be a code as you go basis. Like as I'm coding, you're coding, which I believe is one of the best way to properly, catch up and learn. All right. So any question? All right. Okay. So thank you again for having me today, and thank you for joining in for these sections. And I do hope you did understand, or you can come back to watch the video to get better grasp. And again, you can always reach out to me for more clarity or on the further explanation on any concepts you don't need. We are here for you. Okay. So do enjoy the rest of your evening, and I'll be with you again next week Monday. Bye for now.